what is SAST and what the hell does it have to do with software security? What are the different types of static analysis? I kind of gave it away. We have the manual code review and the automated code review. What does that even mean? What are the code review tools? For example, SemGrep that we're going to talk about, and as well as Psalm that we're going to be talking about. So we're actually going to go through some of these code development tools, and then from there we're going to actually analyze some code. This looks pretty freaking intimidating if you don't understand code or anything like that. So I hope you actually do stick around with us, because we're going to learn a lot of good stuff in our video today. All right, SAST, Static Application Security Testing, is the subject of the video today, and this is going to be our outline here. So we got the intro, the code review, manual code review, automated code review, rechecking the application with SAST tools, and SAST in the development life cycle, the development cycle. So let's jump into this stuff. In order to actually pull this off, there's some prerequisites that you need. So you need to understand what web vulnerabilities are, as shown in the OWASP Top 10. And there's obviously a room for OWASP Top 10, and of course a video attached to the OWASP Top 10 that's already on the channel, so you can go check that out. Then there's the OWASP Top 10. I guess these are, what is it? The various rooms for it. Yeah, so there's both of these. So there's the regular OWASP Top 10 video that we did, and then there's the API security parts 1 and 2 that is also available for the OWASP Top 10. So you need to know all of those things. You need to know web vulnerabilities, all the API stuff, as well as just a general understanding of the OWASP Top 10, and then just a basic understanding of software development lifecycle, which there's also a video of that, so you can go check that out if you want to. The SDLC room is what we did the video on. Not this particular room, but it was a part of the process that we did right here, the secure software development lifecycle. We already did this particular room. So as long as you understand what those things are, you should be good. If you haven't seen those videos, I would recommend that you go check those out before continuing on with this one, because we're specifically going to be talking about static application security, and we've touched on static application security and dynamic application security, as well as the kind of like the hybrid version of both of those things in previous videos. So in this one, we're going to be doing a little bit more of a deep dive into static application security testing, and these are our objectives: just to learn how we can apply SAST to find weaknesses in real-world applications, the pros and cons of using static testing, as well as how we can implement it in a development life cycle. So that's kind of the overview of what we're going to be talking about in this room. So let's talk about code review in a general aspect, in like a general approach, what code review is, before we go into manual versus automated. All right, code review. I mean, it's kind of common sense to think about. If you're looking to secure an application, you want to first look at the code itself. And when you have access to the source code, it's considered to be a white box approach, meaning you actually have access to the source code so you can analyze the source code. If it was black box, you don't have access to the source code, but you can attack the application itself and try to, find different vulnerabilities for the application. But when you have the code, it's considered to be white box. So when you have access to it, you can really go into the nitty gritty, like the deep dive into everything about the code itself, about the application, and kind of look at it behind the scenes or under the hood, so to speak, just so you can see really where a lot of vulnerabilities may be without having to spend time testing or pen testing. And as we covered in previous videos, a cost of a defect or a cost of a vulnerability gets significantly higher as you go through the software development lifecycle. So if you catch it early on, it's obviously much better to be able to do. And static application security testing is done in the design and coding phases. And then when you go from coding to testing between these things, now you start doing dynamic, meaning the code itself needs to run. The application is going to be running, and you're going to be doing dynamic testing. And then when it's fully running and you're in maintenance mode or operation mode, then it's going to be the most expensive to fix any kind of a defect if you discover it at that time. So it's best to do a really, really good job in these initial 2 phases so that you keep the costs low, right? So then to be able to pull that off, we need to be able to use manual and automated tools. And manual code review, as the name implies, is you sitting down line by line and reading the code and trying to find specific vulnerabilities in the code. Obviously, it requires that you understand code and you know what the hell you're doing. Otherwise, it'll be kind of useless for you to try to do manual review. And if you don't understand code, then the next best thing is to use an automated tool to be able to find those common vulnerabilities for you so that you can go ahead and try to find secure approaches to it, or try to find patches to it. Even if you understand code, it would just save you a lot of time if you actually use these automated tools instead of doing it line by line. But I mean, I would say a good security engineer or a good software developer that's focused on security would do both of those things. So there's a lot of stuff, especially if it's like a really big application, there's a lot of stuff that a human can miss. So it's almost mandatory, I would say, to use a lot of the automated tools, and probably some of the ones that we're going to be talking about in this video as well, to use those tools to catch the things that you may have missed and just speed up the process so that you can more focus on remediations and fixing of the vulnerabilities instead of trying to find the vulnerabilities. So that's a really, really big deal. We have a couple of questions for this particular section where it says, is automated code review a substitute for manual reviewing? That would be no. So you do want to also manually review, because you can also be looking at the source code from a different perspective, from a different lens that maybe the tool that you're using isn't looking at that code with. So that's a very, very important thing to understand. And then what kind of review is going to run faster? Obviously, it's the automated review. And what would be more thorough? That would be the manual review, because you're going line by line looking for different vulnerabilities. So that's code review is as a whole. So let's look at manual code review, just to give us an idea of what manual code review actually looks like. There's a machine that we're going to be using for this room with some of the source code inside of this specific folder. That's essentially what all of this these couple of paragraphs at the top are saying right here. And it looks like we're going to be looking at SQL injection vulnerabilities. So to be able to find SQL injection, first you need to understand what SQL is, which is a query language. It's a structured query language for managing databases. And so there's a database engine, which is MySQL, and then the function inside of that engine are as such. And when you're inside of the specific folder, so we're going to change our directory into this folder, we're going to search for MySQL query inside of this specific file that we have, just to see what we can find. And the options that we're using here, R is for recursive searching, that goes and searches through all of the files that are inside that directory instead of just one specific file. And then the N option indicates that we want to find the number of the line that the pattern that we are looking for is in. And so when you run for something like that, you can see that there's a single instance of this specific string that we're searching for. Anything that's inside of the quotations is what we're looking for. And it's found on line 18, as it implies right here. So database.php is the file. Inside of database.php on line 18, the result variable has this thing, right? So when you understand that context, then you can kind of do more thorough of a review. That was the word that they were using. So if we actually open up this file, then we get to look at some of the deeper the pieces of it, just so we can see what's going on inside of it. And this is a lot of stuff. So instead of reading through this, I'm literally just going to go start that machine, and we're going to start reading through each one of these things piece by piece, line by line, so that we can actually look at the code directly instead of looking at various instances of the code. And our machine is up right here, so I'm just going to open up this terminal, and we're going to cd into this specific directory first. And there we go. So if we do a list function, a simple ls, it'll show us all the stuff that's inside of this thing. So what we want to do now is we want to search while we're in here. We want to just run the search query that they had right here, right? The grep search query. And there we go. It gives us exactly that result, right? So we were able to grep for that specific string, and it told us that, you know, inside of the db.php file, which is this file right here, we were able to find the variable that has that string that we were looking for. So easy enough to do a search like that. So if we actually go open this freaking file now, so I'm gonna do, let's see if I can do nano, probably db.php. It should be able to open that file for me. And there it is. And it's going to be on line 18. So assuming that this is line 1 at the top right here, 2, 3, 4, 5, 6. There you go, 18. Line 18 is result MySQL query, yada, yada, yada. And that's what it is. And it's inside of this function for db query. And it shows us some interesting things about it. And it's literally the only thing that's inside of this piece right here. And as we just saw, the MySQL query string that we were searching for is nested inside of this function right here that does a database query. So if we do a search for db query, it'll show us all of the files that is inside of, which in this case is hiddenpanel.php on lines 7, 20, and 23, and attached to these variables. So it shows us that it's doing a query against the database query itself. So, or excuse me, it's showing us that it's doing the database query inside of these hidden panels that are inside of this particular application. It's not a, as the name implies, it's not a visible panel. And these database queries are attached to the various result variables. So we can analyze the context of each of them, starting with the line on, or the call on line 7, and the one on line 7, which is the very first one right here, for the first result variable. It's saying select ID, first name, last name from my guests, where the ID has the equal of this particular string right here, which is the guest ID, right? So what's going to happen in this case is, I guess this particular one was an SQL injection, because they're doing a query. They're doing an actual query right here where they're trying to pull the information of this thing. So it says whatever is passed in the guest ID parameter via the get method that's right here is going to be concatenated to a raw SQL query without any input sanitization, enabling the attacker to change the query. And this particular piece right here is where you, if you sanitize the input inside an application, what you can prevent from happening is from somebody actually doing their own version of an SQL query inside of your application to try to pull data. So when you sanitize input, it doesn't allow them to use SQL queries. If you don't sanitize the input, then they can put whatever they want in it. And then they can make any kind of a command, in this particular case, getting the guest IDs for all of the guest IDs. It's going to get all of the first name, last name, and IDs for those things. So it's kind of important to do the input sanitization piece right here. If we do a similar process for the other two types or the other two uses of the database query that we found on lines 20 and 23, we'll find these results right here. And in this particular case, ID log text from logs, where the ID is this particular, actually no, this is a regular expressions parameter right here, and they're getting the log ID for that specific piece. And in this one, it's the ID name from this particular table, where the ID has these regular expressions, so it's just numeric characters. This one is alphanumeric, as you can see right here. This is just numeric characters, and they're getting the art ID So if we were to look at their explanation here, so on SQL2, which is this piece right here, it's passed through a filter that only allows characters that are either alphanumeric or double quotes. While double quotes may seem like a possible vector for SQL injection, they don't pose a threat in this case, since the SQL sentence encloses the string passed through the get method between single quotes. An attacker would have no way to escape from the string in the SQL sentence. We can be sure that this line is not a vulnerable line. And this is kind of getting like advanced. This room is technically an intermediate room. It's no longer a beginner room or an easy room. And you would need to understand how SQL injection works and how SQL poisoning works to be able to really understand what this sentence means. So if we're going to break it down a little bit more, if we were to review it just one more time and kind of take our time with it. So the alphanumeric or double quotes is this piece right here. So you have alphanumeric right here, separated by comma or double quotes. So these are the two sets of characters that could be replaced, right? So replace. And so in this particular case, it's saying the characters are either alphanumeric or double quotes, while double quotes may seem like a possible vector for SQL injection because you can use double quotes to separate comments or commands, specifically not comments. You can separate commands using double quotes. They don't pose a threat in this case since the SQL sentence encloses the string passed through the log ID. So the SQL sentence encloses the string, meaning in this particular case, it's been enclosed, and the get log ID command right here has been already enclosed with the quote, the single quote, right? So you have the quote right here, then there's a double quote, and this whole thing inside of this double quote goes all the way. So let's see, it goes all the way to here, and then you have another single quote that closes that out for us. So it's an interesting to consider, right? So you have single quote, double quote, and it goes all the way, and then you have double quote, single quote. So this is the entire piece right here. And so since this piece is all enclosed inside of the sentence, you have this last quote that matches this first quote. And so this full thing is a complete sentence, I guess, in this particular case. That's how they're referring to it. So it's a complete sentence. And so since the quotations are set up correctly and everything's designed in this query correctly, it's not a vulnerable query. So that's what we need to understand. So a single character could ruin an entire line of code. If you've done any kind of coding, literally a comma in the wrong place or a quotation in the wrong place can break the entire query or the entire software or the program, the script that you're running, whatever it is. A single character could destroy everything. So as long as you have all that stuff figured out and designed correctly, if the syntax is designed correctly, you should be fine. So in this case, they don't pose a threat in this case since the SQL sentence encloses the string that's passed through this thing between single quotes. Since the attacker would have no way to escape from the string in this sentence, they can be sure that this is invulnerable. And to escape from a string, you would use either a single quote or a double quote to be able to run some kind of an injection attack. That's what escape means, and it's done through the usage of quotes at the end of a specific query. So if this was not a secure query or a secure sentence, you can escape it. So for example, if this last quote was missing right here, you could be able to escape this whole thing using the quotations, and then after this, you can run your own injection attack after the fact. And it seems complicated. It is complicated, honestly. If you really do need to understand PHP and SQL languages to kind of understand what just happened there. But the more you watch something like this and the more you do exercises like this, the easier your head will wrap around concepts like this. So it's not easy if this is your first time looking at it, which is why it's important to watch all the preceding videos to this kind of video. But if you do understand PHP and if you do understand SQL, you should understand what we just talked about. The query on SQL3 is even more restrictive, allowing only numeric characters to go through the get art ID, and the preg replace function is called with a third parameter that is set to 1. If we refer to the manual page of the function, we will learn that the third parameter indicates the maximum number of replacements that can be done. Since it's set to 1, only the first character that isn't a number will be replaced with an empty string. Any other character that are passed through it without being replaced enable SQL injection. This is a vulnerable string. So only the first character that is not a number will be replaced with an empty string. Any other character that are passed without being replaced can be any kind of SQL injection that you can have, which makes this specific variable, in this case, it makes this one vulnerable. And that's it for our manual reviewing. This particular application was a very straightforward one, a very basic application. A real application is going to have a lot more files and many more lines of code, therefore making it much more complicated. But it should be pretty obvious that manually reviewing large code bases can quickly become tedious, obviously, just based on what we just went through, especially if you don't understand PHP languages or SQL or anything like that. It just becomes a big pain in the ass, honestly. So what we're going to do is we're going to go and use some nice tools to automate some of these things for us. So there's a bonus exercise here that says using manual code review to find out the type of vulnerabilities in the provider project. The following questions will guide you through it. So locate file inclusion, LFI attacks, local file inclusion LFI attacks are made possible by the misuse of one of the following functions in PHP. So require, include, require once, include once. Answer the following questions using grep to search for LFI vulnerabilities only on the .php files in the directory HTML for our project. So what we're going to do is we're going to search for those particular strings, I guess, which of the mentioned functions is used in the project, include the parentheses at the end of the function name. So I'm just going to create another grep command here, and we're just going to search for these various things. So let's see what we can find. Okay, so that one returned a result for us. And let's just go and do require as well. Oh, that one returned a result for us too. So require returned a big ass result, and so did include in this particular case. Wow, look at that. Yeah, so I am going to run the include one more time, because I think the include one was the only one that gave us the PHP files right here. So it's login PHP, gallery PHP, hidden panel, view, so on and so forth. So the include, let's see if that is indeed the one. Yep, that is the one. So how many instances of the function found in question 2 exist in the source code? So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 instances. And of only one of the function instances is vulnerable to local file inclusion. Remember that for LFI to be present, the attacker must be able to manipulate a part of what is sent to the function. So the vulnerable instance must contain some reference to a get or post parameter, or manipulate inputs. Which file contains the vulnerable instance? So what we're looking for is something that has a reference to a get or post parameter in the input, and what line in the file is vulnerable to LFI. So I am going to now search through each one of these files. It's going to take me a minute, but I will go ahead and edit that out, and from there we'll try to find our specific file. Okay, so actually just kind of skipping through the manual search of everything, it's asking us to find the one that is It has a get command inside of it, and none of these, with the exception of this one specific file, have a get command inside of it. So this actually makes it a little bit easier for us to search for this. So that's actually the view.php file, and the line of that is line 22. And just like that, we were able to find the answer. I kind of cheated because I looked at the phrasing of the question, and they kind of gave us the answer inside of the phrasing of the question. We were supposed to look for this get request right here, and none of these have a get request other than one particular line. So that one kind of made it a little bit easy, so we can kind of cheat that one. So now let's go actually into our automated code review so that we can actually use some of these tools to make this process a little bit easier for us. Okay, so here's where it's going to get a little bit interesting. We're going to be using automated tools, right? Static Application Security Testing, SAST, refers to using automated tools for code analysis. It's not to replace manual code review, but to provide a simple method to automate simple code checks and quickly find vulnerabilities. It complements other techniques such as dynamic application security testing, which is going to be our next video, or software composition analysis, and to provide a holistic approach to application security during the development lifecycle, because this is the cheapest part of the lifecycle to fix any kind of a problem. Just as with any other technique, it has its pros and cons. So pros, it doesn't require running instance of the target application, so you don't have to run it. It's great coverage for the application's functionality. It runs fast, and as opposed to other dynamic techniques, which means you're running the application itself. The tools report exactly where vulnerabilities are in the code, and they're easy to integrate in your CI or CD pipeline. And the cons are source code of an application is not always available if you're using a third-party app for analysis. For example, if you're trying to find security vulnerabilities, so you can't always find source code. It's prone to false positives, as with any other type of assessment. You can't identify vulnerabilities that are dynamic in nature, meaning it requires for the app to be running to be able to find those vulnerabilities. And SAST tools are mostly language specific. They can only check languages that they know. So if you want to check PHP, you need to have a PHP tool. If you want to check Python, you need to have a Python tool, so on and so forth. Under the hood, so while most of the tools are different, or every tool is different, most of them will perform two main tasks: transform the code into an abstract model and analyze the abstract model for security issues. So instead of you just having to look at lines of code and trying to find it inside lines of code, it's going to transform the code into a model that is relatively easier to work with compared to just looking at source code. And they represent the code using something called the abstract syntax trees, AST. But some tools may have other equivalent properties. This allows for easier code analysis. It's crucial for later analysis, as many features of programming language that isn't correctly translated into AST will probably not be analyzed for security issues effectively. And then once it has the abstract model, it'll analyze it for security issues. During this particular room, we're not going to be going into modeling in detail because this is a really big topic. You could do an entire course on this topic. So we're going to be looking at specific analysis techniques that are commonly used by static analysis tools. So semantic analysis, it's a type of analysis that is compared to grepping, meaning searching, for potentially insecure functions. While doing manual code reviews, it aims to find flaws concerning the use of potentially insecure code. Examples of this includes what we did when we searched for this specific query piece where the get or post parameters are directly concatenated into the query string, and this was the result that we got. Or not this wasn't the result that we got, but it was similar to what we got when we ran it. Then you have the data flow analysis, and where these are situations where potentially dangerous functions are actually in use, but it's not clear whether or not a vulnerability is present just by analyzing the local context around the function. So this particular function which was the big function that I think this was the first one actually when we did the grep for this particular piece. It brought us this entire function, or it brought us this line, excuse me. And then when we looked at the db.php file, we saw that that was the function that it was nested in. By looking at the code, it's hard to say that there are any vulnerabilities. So we had to do a second search for this piece, and then we found the file that actually had the vulnerabilities. Data flow analysis is going to trace how information flows from inputs that the user can manipulate to potentially vulnerable functions, just as we did when we manually analyzed the provided application code. In data flow analysis terminology, data inputs will be referred to as sources, and potentially vulnerable functions will be referred to as sinks. And if data flows from a source to a sink without sanitization, then we have a vulnerability. Going back to the DB query, data flow analysis would have to find all the usages and trace it back to any tainted input, which is the source, to see if anything is sent to it, and it ends up as part of the query executed by MySQL query, which is the sink. So this is the source, and this is the sink. And then this is what it will look like in the actual URL of the API or the application itself. So the guest ID equals 1 tainted runs to the SQL variable, which is also tainted, which runs to the database query, which is also tainted, which runs to the MySQL query. And this is literally going through the whole thing that we found. It's actually in a previous task, so I'm not going to go. You can just kind of review back. You can go back in the video to find it, but it was that original source code that we found, that it was doing a query to find the guest IDs and pull the ID, the first name, last name, so on and so forth for that. And so if somebody goes to the API of the application and at the end of the call just puts guest ID equals 1 for whoever this person is, it's going to pull all that information from that guest ID, because none of these things were sanitized, and being all of them are tainted. So opposite of sanitized is that it's tainted. And then it pulls the information that the person would want, the attacker. Then we have control flow analysis. It analyzes the order of operations in the code in search for race conditions, use of uninitialized variables or resource leaks. As an example, we look at this piece of Java code right here, and if the command property isn't identified, the call to system get property will return null, meaning nothing. Calling the trim method from a null variable will throw an exception on runtime. So this thing, calling this on this is going to throw an exception on runtime. So during the runtime, it's actually going to run an exception. And oh, you know what? I just noticed that there's also these nice little icons that I guess represent all of these things. So semantics would be searching specifically for each individual line of code. The data flow, as the funnel implies, we're going through the flow of the data. Control flow would be going from this to this to this. And if it's not defined, if CMD is not defined, it's going to return null. So if, for example, if this isn't defined, then this will return null, I guess. Or if this isn't, I'm not understanding this part actually. I don't know which flow, where that runs through. And then you have structural analysis, which seems to be the most complete. It analyzes specific code structures of each programming language, and it includes following best practices: we're declaring classes, evaluating code blocks that we never execute, which is dead code, correctly using try and catch blocks, and other issues related to using insecure cryptographic material, which could be weak keys or IVs. IVs, I wonder what that stands for. So this is a piece of code that would be detected by structural analysis. And in this case, we have an implementation of an RSA with a key size of 1024. So this is the, I think it's real secure algorithm. That may be the wrong breakdown of that acronym. But the key size is 1024. and considered insufficient by today's standards because there's much larger keys, much more secure cryptographic algorithms. So this would be the entire piece. So you have the entire thing that's going to come from structural analysis. And then the configuration analysis goes and looks at configuration files. So searching for an application configuration flaw rather than the code itself. As an example, applications running under Internet Information Services will have a configuration called web config. PHP will hold all the configuration options in a file called PHP ini, and most applications will use some configuration file. By checking configurations, the tool will identify possible improvements. Here's an example of 2 configuration directives in PHP that would probably raise an alert on SAST tools as they facilitate some attack vectors for remote file, RFI, SSRF, server-side request forgery. I know that what that is. Remote file inclusion. I want to say that might be that. And so let's see. Allow URL include on, allow URL fopen on. These are some configurations, some permissions that may trigger or trigger an alert inside of the SAST tool. So not every SAST tool will implement all the analysis techniques that we discussed, but it's good to have them as a reference to compare different solutions that exist, meaning different tools that exist. So some of these questions, I don't think we have to look at any code. I think it's just based on the material that we just read. So does SAST require running an instance of the application for analysis? It does not. What kind of analysis would likely flag dead code segments? And that's going to be this particular one, which is the structural analysis that looks at dead code. And so we're going to go over here. And what kind of analysis would likely detect flaws in configuration files, which is configuration analysis. And finally, what kind of analysis is similar to grepping the code, which is the very, very first one at the top right here, which is semantic analysis. All right, there we go. We got our automated code review. So now we can kind of go through, I would hope, the tools that we're going to be using and do some actual code review using tools. And yeah, we're about to use a couple of these tools, and we're going to be going through the simple app folder that's on our desktop in this practice machine. So SALM, PHP static analysis linting machine. It's so funny, like almost everything in cybersecurity is an acronym for something else. And I wonder, what came first? Did the acronym come first and then this thing came up first? It's just it's so funny. Sometimes they're like, dude, they had to design this whole name just so it can turn out to be this kind of a acronym, because it seems just too convenient for the names to be matching. Anyways, whatever. So we're going to use SALM, which is a PHP tool, as the name itself just implies. It's already installed on our machine, which is nice. You can always go ahead and download it or use their website to download it. We're going to go to the project's directory, and the SALM XML file is going to be at the root of the project. And this is the config file, which I guess is going to be the one that we're going to be working with. Error level resolved from config file, the XMLNS domain or the URL for it, or the XSI, and then this is the root XMLNS. XSI schema location is at that URL. Find unused baseline directory, yes. And then the project files are going to be going for everything inside of the HTML directory, I believe, and the vendor directory. So we're not going to go too deep into this, but you can see that the error level parameter, which indicates how strict the SALM is going to be running with issues, the lower the value, the more issues will be reported. There's also a section called project files, where the files to be scanned are indicated, which we already established. So we're going to be going inside of the simple web app, not the HTML folder that we were already in. and then we're going to run Psalm. And from there, we should be able to get some kind of an error, I guess, and see what we'll find. It's going to only run structural analysis over the code and shows us programming errors that need our attention. In the previous example, it reports the condition on the if clause is always false. In this case, the programmer mistakenly used the assignment operator equals instead of the comparison operator, since the assignment operator always returns the assigned value. So it's basically saying that instead of checking to see if something is false, it's going to actually assign it as that value. So that's not good in this case. Since the assignment operator always returns the value, 0 in this case, the condition will always evaluate as false, and it'll automatically cast to false in PHP. So it's supposed to use a comparison operator, not an assignment operator. The default test will search for issues with variable types, variable initialization, and other safe coding patterns. While these are not vulnerabilities, it'll make recommendations so the code follows coding best practices, which is always good. It also offers the possibility to run data flow analysis using the taint analysis flag. And the output for this is going to be much more interesting because it's going to pinpoint security issues, which is always a good thing. And this is what it will look like in this case. So tainted include, detected tainted code passed to include or similar, the get no known location, get image, concatenated, yada yada yada. For each error reported, Psalm will show you a complete trace of the data from the source get to the sync function include. Oh, good. Okay, that's what that looks like. Okay, so this whole thing is one thing right here. We have a typical local file inclusion vulnerability, and the get parameter image is concatenated directly into the file name passed in the include function. Data flow analysis usually gets the most interesting findings from a security standpoint. However, other structural findings are equally important to fix, even if they don't directly translate into an exploitable vulnerability. So structural flaws can often lead to business logic errors, and it's going to be cost intensive. So it's going to be expensive to fix. That's probably an easier way of saying it. It may not necessarily be a security vulnerability, but it can crash at some point, or it can be a pain in the ass, really. False positives and false negatives. So a false positive is a vulnerability that doesn't actually exist, that was assumed to exist, and so you got a false positive, meaning that this is a vulnerability, you need to go check this out, and it was never a vulnerability. A false negative means that there is an actual vulnerability and it was never brought up by the tool. So when you have situations like this, I would say it's just best to use multiple tools against some source code to see which one catches what thing and which one misses, so they may present themselves, the tool can't correctly process it, so they can also be introduced if we don't use the tool correctly. As a quick example, when we manually review the code, we found 3 possible instances of injection. Still, we discarded one of them as a character filtering, and leaving us with 2 confirmed SQL injection vulnerabilities. If we check Psalm's output, we notice that only a single instance is reported. The first one, lines 6 to 7 of the hidden panel, which means that there was a false negative. So since it didn't detect one of the vulnerabilities that we found manually, that means it gave us a false negative in this particular case. So let's comment out lines 6 and 7 hidden in the panel and see what happens. And by commenting, it's not Python, so you would have to comment with the forward slashes. And if you do that, we should have no more errors. However, if we execute, it says that now it'll report a different tainted SQL error corresponding to one of the 2 queries. So let's see, hidden panel PHP 1987, hidden panel PHP 665. So it's showing us a completely different one. And why didn't it? That's actually my question too. It's like, so why didn't it detect it the first time around? It can be found if you check the first line of both errors, both show line 18 of DB as the source of the problem. For some vulnerabilities, they're the same and related to how you call MySQL query on line 18 of DB. In other words, it expects you to apply a fix on the DB file as well, as it doesn't understand the code. Defines DB query as a wrapper to any database queries. Before continuing, make sure to uncomment 6 and 7, and which is this particular line right here, these two lines. We can use annotations to give us more context. DB query should be considered a sink, so we get an error if any tainted input reaches that via the query parameter. To do so, add the following comment on top of the DB query, which defines what's going on right here. So this comment explains, right? So the SOM taint sink is SQL query, and SOM taint specialize. Annotation tells SOM to check the query parameter for tainted inputs of the SQL. Now SOM will issue a tainted SQL error every time a tainted input reaches the database query. We also need to add the SOM taint specialize to tell SOM that each invocation of the function should be treated as a separate issue, and it depends entirely on the input that it receives. So you would get both of them separately, and after rerunning it, we should get all of the instances as expected, and now you have a much bigger result. Look at that. So you'll get a third error repeating on one of the previous ones because MySQL inquiry is still considered a valid sink. SOMS has a built-in list of default sinks, so you should still have the original alert on top of the new ones. And if we compare the results with the manual review, you'll notice that there are some differences. So manual review, these various parameters we've established as this type of a result. SOM made this one. So this one was the same. And this one, in this case, is a false positive because SOM said that it was vulnerable when we determined that it wasn't vulnerable. And in this one, it said that it's not vulnerable when we determined that it is vulnerable. So therefore, this was a false positive and this was a false negative. A certain level of false positive and negatives are always expected. As with any other tool, you must manually check the report for any errors. SAST is an excellent complement to manual reviews, but should never be considered as the replacement of a manual review. In my humble opinion, this is really, like, you really need to understand coding. This can't be done by somebody who doesn't understand coding and various coding languages. There is, as they mentioned right here, you can't just assume, you can't use specific tools as a replacement for manual reviews. You need to be able to understand the language enough that you can manually review something, specifically in these situations too. Because it's one thing for SOM or any tool to say that this is a vulnerability and it ends up being a false positive. It's a whole other thing for it to not detect a vulnerability and it says, oh yeah, there's no problems here, and then there's actually some kind of a weakness there, and then you miss it because you don't understand the code, and that ends up being a big hazard down the line. So question, what type of errors occur when the tool reports a vulnerability that isn't present in the code? That would be a false positive. And how many errors are reported after annotating the code as instructed in this task and rerunning SOM? So we actually have to do that. So let's go and check this out right here. Just based on this output right here that we got on our screen, I'm gonna just venture a guess of 2 because I only saw 2. And let's see, that is incorrect. So we actually have to go and annotate this thing, and from there try to find that answer. So let me go and do some of that work. I just read through it instead of doing the code itself. So let's do the exercise. Okay, so actually just running the very first piece right here, we can see that there is definitely much more, many more results that came out than the stuff that we see on the screen. And that actually shows us right here that there are 9 errors that were found when I just ran this very basic command at the top right here. So now let's make some modifications to this to see what we can find specifically for the annotation. So I'm going to go to the portion with the annotation, and from there we are going to find the answer to our question. Okay, so before making the annotation, actually I want to do a test of the results just to see what we're going to get. So I'm going to run the command, and I'm going to do no cache, and then we're going to use taint analysis, and let's see what we get here. So we got 7 errors that were found without making the annotation. So now that we have this results, now I'm going to go and make the annotation inside of the db.php file right here. So let's go inside of the HTML directory, and we're going to nano into our db.php file, and we're going to come down to the portion where we want to make the annotation right there. So here we go. I'm going to create a new line, and here we go. Okay, there we go. That's all I got. So som taint sync SQL query, som taint specialized, som taint sync SQL query, and som taint specialized. There is our annotation. So now what we're going to do is we're going to save this, and we're going to exit out, and then we're going to run our command one more time, actually. So I need to get out of this directory and go to the last directory, and then we're going to run our command one more time with the taint analysis. Let's see what we get. Okay, so last time we got 7, and this time we got 9. So let's see if 9 is the answer. And it is. Look at that. We figured it out. We got it. Just to give you guys a heads up, I am not great at PHP coding. The coding languages that I'm most fluent with are HTML, XML, and Python. PHP is a learning curve for me. I can conceptually wrap my head around what's being talked about here, but I just want to kind of be transparent and honest with you. I really, there's a lot of stuff that I still need to learn about PHP, which is why I mentioned at the very beginning, or not the very beginning, at least previously, maybe a few minutes ago, 5-10 minutes ago, that it's important to understand the language itself. Otherwise, you're going to miss a lot of possible vulnerabilities. So that was that. So now we're just going to look at static analysis in the development lifecycle as a whole. Static analysis is one of the first tools to appear during the development lifecycle, meaning during the coding stage, because you don't need to have a functional application to use it. You don't need to be able to run the application because you're literally just looking at the source code. And this is the secure software development lifecycle. We already did a video on this, so you can go check that out. It goes into much further detail than what we're just going to be covering right here. But these are the phases of the secure software development lifecycle. You have 8 specific phases: the development phase right here, and then the operation phase right here. And depending on the case-by-case situation, depending on what your specific software is and the application and what you're going to be doing, it can be implemented in one of 2 ways. So you have the CI/CD integration. Each time a pull request or a merge is made, the tool is going to check the code for vulnerabilities, and checking pull requests ensures that the code that makes it to merges has gone through at least a basic security check. On some occasions, instead of checking every single request, executing SAST scans only at merges can help prevent slowdowns in the development pipeline, because it avoids making all developers wait for the full scan. Then there's the IDE integration. Tools can be integrated into the developer's favorite IDE instead of waiting for a pull request. This way the code can be fixed as early as possible, saving the time further ahead of the project. And one of the greatest things that you can see, for example, I'm going to actually pull up PyCharm, because PyCharm is an IDE. And what it does, and let's see, I'll just open up a file here. We'll do this one, whatever. We'll just open up this one. Let's see. I need to open it. I need to bring it onto our screen here. So we're going to bring it over here. And here we go. So this is our tool, right? What the recommendation right here, the IDE integration. What this does, and this is for Python language specifically. This is not for PHP. But what you'll see here is that there are these little squiggly lines that are underneath all of these pieces, and none of these things are really big errors, okay? So if I make a big error, so let's just right here, I'll do print error. You see how there's a red line under it? That is a real problem. That's something that, and then especially when we go here and then this little light bulb pops up and it says import this name locally, create a parameter called error, rename it, so on and so forth. So it actually does real-time problem resolution for you if you have made some kind of an error, right? So if I want to go to reference what? If I want to reference, let's say, this thing, I'll just reference this list. So if I want to reference that list for myself, I can do the proper, and this is another cool thing, is that it'll like help you autofill these things for you, right? So you can either give you the thing that you're looking for, but if I misspell it, it'll again give me some kind of error, and then it's not going to run, and it's going to say, hey, you need to fix this, and then you click on the light bulb and it says create it or rename it, so on and so forth. So this is what it means when they say integrate with an IDE. PyCharm is an IDE for Python and also for a lot of other types of documents. So you can work with CSV documents, you can work with text documents, you can work with HTML documents, so on and so forth. So it's not just inclusive to Python itself, but it's designed for Python specifically. And it'll help you do problem resolution and error resolution in real time. So what you can do is you can integrate various tools for PyCharm. So you can integrate a tool for Python. Let's see, we can actually even search for that just to see. Okay, look at this. Just a simple Google search, right? So I searched for Python SAST tools that can integrate with PyCharm. And then right there, the Google AI found this for us. So we have PyLint. By installing PyLint via the command line, you have Codana, you have Bandit, SemGrep, so on and so forth. And I actually might start using these things just for my own coding exercises as well, because it's useful. It's useful to have something that'll be like, hey, you might need to check your code for whatever, and it integrates with your IDE, so you don't have to make a request, as they said right here. So a pull request, you don't need to make a pull request to check the code for any kind of errors. It can just do it as you're developing your code. So I think that's very useful. That's kind of cool. And I would recommend you do it as well if you're thinking about going into software security and checking source code and stuff like that. I would highly recommend that you do something like that as well. So you may want SAST running on both the developer's IDE and your CI/CD pipeline, which would be valid, and CI, continuous integration, and continuous development. That's what those things stand for. Yeah, there you go. Okay, so you may want SAST running on both the developer's IDEs and your own pipeline, which should be valid. For example, the tools may run basic structural checks or enforce secure coding guidelines, while the integrations may run more time consuming data flow taint analysis, and your specific setup will depend on what you actually need. We can go to the DAST room, and which is the very next room that we're going to be doing. So that'll just be in the next video. For example, integrating a DAST tool into a Jenkins pipeline, and it's pretty similar, so we're not going to repeat any of those things in this particular video. Integrating SAST in IDE, so you have Psalm, that can be integrated. You have semgrep, and I think semgrep was also one of the things that showed up in our Google search that can be integrated. Let's see, directly from the marketplace. There it is. So I'm actually going to open this up in a new tab. It usually opens it up in a new tab for us, but this time it didn't. And now we are stuck with our window looking all kinds of busted. So I got to get out of this and then get myself a position where I can zoom back out. So let's see. Okay, here we go. And then we're just going to open this up in a new tab. And this is the semgrep website if you wanted to use semgrep to integrate into your IDE. And this is the one for SOM. And the tools will work similarly by showing any problem detected directly in line with your code. And look at this. This looks very similar to what we just saw on PyCharm, right? So it actually shows you the errors in each file. It shows you where they are, and it gives the same type of red squiggly line to help you notice where the error is. And then if you click on it, it'll actually give you the breakdown of the error so that you can go ahead and fix it. We can also check the complete set of issues by clicking the errors indicator right here, and it gives you all of your stuff in a line by line format, a line item, and it's right here. Python also has the same thing. So let's see if I can go back to my file. Did I already close my file? I think I already closed the file. But Python actually has a very similar, PyCharm, excuse me. PyCharm also has a very similar thing right here where it gives you this little button that you can click on that will show you all the errors and all the potential errors and all the really bad errors. So having the IDE check for problems allows you to produce cleaner code as a developer, contributing significantly to the overall security of the final application. Using both of these, we can go ahead and answer the questions right here. So I guess we actually have to go ahead and try to figure this out. So for this task question, we'll analyze the old version of Reci.php, a small open source app. Before continuing, make sure to open the Code Workplace icon on the desktop. It'll open a VS Code Workplace and where the project is. So on the desktop, let's see what we're looking for. Okay, so I opened this inside a new window because it would be too much if we tried to look at it in half the window. And it did take a few minutes to load. So if you're doing this on your own, you got to give it a couple of minutes to fully load everything. And here's the number of problems right here. So it says there are 27 total problems that have been detected in our workspace. So now how many problems are detected in the show recipe inc PHP file? So let's go and find that one, which is right here, show recipe inc PHP. And there are 8 problems in that file. And so we're going to open it, and there are 2 types of problems being reported. One is identified as tainted SQL string and refers to the SQL injections. What other problem identifiers are reported? With write the ID reported by semgrep. So we're going to open this particular file, and inside of this thing we have these things. And so let's see, we're looking at the ID, and so let's see. I see, so this one right here, this is the semgrep tainted SQL string, and so in this case semgrep echoed request would be the other one. So we're going to type that in. And what type of vulnerability is associated with the problem identifier on the previous question? What type of vulnerability is associated with it? And the vulnerability is cross-site scripting. So that is our vulnerability that is associated with the echoed request. Look at that. Just like that, we just finished our room here. So not bad. This was pretty informative. And I personally learned a lot. I think I actually have to go through this a couple of times just to really wrap my head around it. And I'm glad I actually got a chance to record this video. These videos, believe it or not, these videos help me just as much as they help you. So I hope you found this useful, honestly. If you did find it useful, I would very much love for you to join our community. Our community has actually been growing pretty steadily, and honestly, I'm really happy about it because Just in the last day or two, we got a large surge of subscribers that came in just because of some of the compilation videos that have come out. So I'm very happy to see the community is actually growing. I would love to have you as a part of the community, and I answer all the comments that come in, and if they're really robust comments, I do make videos to respond to those comments. So it would be amazing to have you as a part of our community, and I really hope that you get a lot of value out of it. It's your boy Hank Hackerson at Hank Hacks Hackers, your favorite network and system attacker / protector. If no one else loves you, Hank loves you. Love, peace, and chicken grease. And I'll see you in the next video. Later.